Okay, today's lesson 12-19 happens to be right triangle trigonometry ratios. All we're going to talk about today is just the ratios. Okay, we'll start solving triangles tomorrow. Okay. All right. So we know that in a right triangle, and I'll just draw a picture. You don't have to draw this picture. Okay. You know, in any right triangle, here's my angle. Theta is my angle. Right. That's my symbol for angle. Right. As the angle increases or decreases, so does the other side. So if the angle gets bigger, then the opposite side increases or decreases, right? So there's a definite relationship between the angle and the sides, right? It's a right triangle. That makes sense. So what we want to do is talk about these ratios. Now, every possible ratio you can think of is actually in your calculator, right? But some of the ratios, like from our special right triangles, 45-45, 90, and our 30-60-90, some of those special ones we can actually do without a calculator. That's kind of what we just practiced, okay? So let's take a look. We do know sine, which we talk about. Sine is equal to the opposite side over the hypotenuse. Okay? And we just say S-I-N, sine theta. It's not sin. It's not sin. That's for church. It's sine. Okay? And in your calculator, you'll see a button, S-I-N. Okay, S-I-N. Now, it's real important for us also, though, to make sure we always, if we use our calculator, check our mode. Check, write this down, check mode. In fact, I'm going to highlight that. That's so important to check our mode. Got to highlight that so we don't mess that up. Okay, on rare occasions, you can do the entire test correct, get every problem wrong. On rare occasions, you can do the entire, you see, angles can be done in two different ways. If I go to my mode, I have angles in radians, which we're going to learn about radians, but not today. And we have angles in degrees. We want our angles in degrees, because if it's a triangle, it's in terms of degrees. 30 degrees, 60 degrees, 45 degrees, right? We will learn about radians once we get to that circle, okay? Yes?
What happens if we end up doing the test accidentally with the whole radian?
Right, it's a real bummer. So you don't want to do that, okay? Right, so that's the whole idea, is that we don't want to do that, okay? So you'll basically have to do it again. I will do my best to remember to tell you change the mode, okay? So degree mode, always, and here until we get to radians, okay? Now, Vicky, did you use past? Did you have your little past that I can mark off? Okay, if you get it for me. So now, cosine is equal to the adjacent side over the hypotenuse. So it's a ratio. It's a ratio. As one side gets bigger and the other side gets smaller, the angle changes, right? It's a relationship between three things. Two sides that can move and the angle, right? So that kind of makes sense. Okay, and it's just cos theta again in your calculator. There it is. It says cos, but it means really cosine, okay? In your calculator, it's right there. It says cos. Okay, now, we also have tangent, which is equal to the opposite side over the adjacent side. Tangents probably used more than any of the three, because most time when you're doing things you can measure, like for instance, I can measure the floor and I can measure the ceiling, right? Or not the ceiling, but the wall. Those are things. So tangents used the most out of all applications, and it's tan of theta, okay? And again, that's in your calculator. Okay, tan, T-A-N, but it stands for tangent, not tan, okay? Now, cosecant, secant, and cotangent are not used very often. Very rarely are they used in real-world situations, but they are mathematical terms, so let's take a look at it. So the cosecant is the opposite of cosine. So, oops, I said that wrong. Cosecant is the opposite of sine. My bad. It's Monday morning. Okay, so cosecant is the opposite of sine. So cosecant is going to be the hypotenuse over the opposite side. And it's going to be CSC theta. Okay, CSC stands for cosecant. Now, you do not have a cosecant button in your calculator. You don't. You don't have a cosecant button on your calculator. But it's the same thing as 1 over sine. And if we have to use a calculator, we're just going to remember that we're going to go 1 over the sine of that, okay? Now, secant is the opposite of cosine. See, okay, so secant is the opposite of cosine. And so it's going to be the hypotenuse over the adjacent side. Okay, and it's going to be SEC theta. Okay? You don't have there's no secant button. Sine, cosine. There is no secant button at all. So we need secant, it's just going to be 1 over cosine of theta. Okay, so if you need to use your calculator, you're not going to put, there is no secant button. There isn't. But you're just going to go 1 over cosine. Okay, now the cotangent button is obviously the opposite of what? Tangent, right? Does that make sense? So it's going to just be the adjacent side over the opposite side. And it's going to be COT. It's not really cot. That's not the name. It's cotangent, okay? It's cotangent. So cotangent of theta, again, there is no button. There's no cotangent button, but there's a tangent. So if you ever need to use cotangent, it's going to be 1 over the tangent button if you need to find that, okay? And we're going to practice this in our notes, okay? All right, thumbs up. This should be stuff everybody knows, right? Agreed? You guys learned this last year in geometry. Now, let's do this. I want you guys, angle B, find all 6 trig ratios. So do this real quickly. I want you to find the sine of B. Okay, you can do this. Cosine of B. Find the tangent of B. Find the cosecant of B. Find the secant of B and find the cotangent of B for me. Okay, go. Get her done. You can get this done in 60 seconds or less. I'm positive. I know you can get this done. I'll give you 60 seconds or less. You can get this done. And if you forget what they are, that's why they're up there on the board, right? But they are also in your notes. Yep. Get the first one right though. Hypotenuse is always the longest. It's always the one opposite. And the adjacent is the one next to it. Okay. There you go. Okay. So let's see. Oh, John, what'd you get for sine of B? 4 over 5 because it's the opposite side of the hypotenuse. Nice job. Lily, what'd you get for cosine of B? Because it's the adjacent over the hypotenuse, 3 over 5. Caden, what'd you get for tangent of B? 4 over 3 because it's the opposite over the adjacent. Okay, so one more time, how do you figure out what the name of these things are? Here's your angle, it says angle B. So think about this, you're sitting, you're chilling at angle B. It's a big old lake here. So if you had to throw a rock to the opposite side, that makes that the opposite side, right? The hypotenuse is always the longest, or it's the one opposite the 90, That makes the 3 the adjacent, because adjacent means next to. Okay, good. Ethan, cosecant of B.
5/4.
Yeah, how'd you get that so quickly?
It's hypotenuse over opposite.
Awesome. And it's also the opposite sine. Now that makes it real easy. Isaac, what'd you get for secant of B?
Secant of B. What is it? 5/3.
5/3 is correct. 2 ways. One, it's the hypotenuse over the adjacent, or it's the opposite cosine. That makes it easy, doesn't it? And then cotangent of B. Autumn, what'd you get for cotangent of B?
3/4.
How'd you get that so fast?
Opposite.
That's the way I do it. It's the opposite tangent, right? I mean, you can still do it's the adjacent over the opposite, but that's fast. Okay, guys, ready? Okay, want to write those down? Leah, thumbs up. Okay, thumbs up. Pretty easy, right? Okay, so turn the page and let's see what we have on the other side, okay? So, example 2. Well, we get sine of some angles 5/13. Well, let's see. Here's what I know about sine. Do a little work up here. Sine of an angle is equal to the opposite over the hypotenuse, right? So let me write that down. I know sine of any angle, so I'm looking with sine. I don't have a triangle. It'd be really nice if I had a triangle, right? So let's draw a triangle. So draw a triangle. So draw a right triangle. So I'm going to draw a right triangle, okay? And I'm going to put theta right there, okay? How's that? So just draw a right triangle, okay? It makes it easy if you draw a right triangle, okay? So here's what I know. If sine of theta is equal to 5/13, then the 5 has to be the opposite, because I know sine is opposite of hypotenuse, so 5 is my opposite, and my 13 is my hypotenuse. Okay, one more time. Here's how it works. Okay? So this is going to help me draw my triangle. 5/13, sine is the opposite of hypotenuse, so on my triangle, the opposite side is 5, my hypotenuse is 13. Does that make sense I'm doing that? So I'm going to go to my triangle and say, okay, 5 is my opposite side, and my 13 is my hypotenuse, okay? Because again, if that's where I'm sitting, the 5 is my opposite side, and the longest side, or the opposite one from the 90, is my hypotenuse. Okay, now what I don't know is my adjacent side. Yeah.
Is it 5?
My adjacent side, I don't know what this side is, right? How would I find this side? Yeah.
Would you switch sine and then figure out the angle from there?
I could, but I'm still got to find that side. I still need a number here. I need a number here. How do I find that side? Don't tell him, John. Somebody in here should know how to find this. How do you find this side? The dude's name starts with a P.
Hypotenuse.
There we go. Who said that? Pythagoras theorem, right? So a squared plus b squared equals c squared. So let's go a squared, or let's do our opposite. Write this down. Opposite squared plus adjacent squared equals hypotenuse squared. Please write that down. That is Pythagoras theorem. So a squared plus b squared, we're going to write it as opposite squared plus adjacent squared equals hypotenuse squared. Same thing. Write that down, please. We're no longer going to say a squared plus b squared equals c squared. We're going to say opposite squared plus adjacent squared equals hypotenuse squared. Okay, now this is easy. So I got 5 squared plus my adjacent squared, which I don't know what that is. That's, now I probably could call it b squared equals my hypotenuse squared, which is 13, right? How am I doing? Okay, now let's solve. So, okay, write that down, right? 5 squared, because that's my opposite, plus b squared, I don't know, b squared, right? Equals 13 squared, so I've got a 25 plus a b squared equals 169. I just happen to know these numbers. I've been doing this for forever and ever. Okay, and then if we're going to solve b squared, I'm going to go minus 25 minus 25. B squared equals 144, right? How am I going to solve for b squared? What am I going to do?
Square root.
Yeah, square root, right? So what's b?
12.
Now that's the adjacent side, isn't it? So let's put my 12 right there. Okay, let's put my 12 right there. Am I going too fast? Am I going too fast? Am I okay? All right, let's do it. You guys can do it now. Tell me. The sine of theta, we already know that one, 5/13. Cosine of theta, you can do that. Tangent of theta, you can do that. Cosecant of theta, you can do that. Secant of theta, you can do that. And cotangent of theta, you can do that too, okay? Take a second to get those, okay? Here's my triangle. Okay. Cosine of theta. Vicky, what'd you get for cosine of theta? 12 or 13. Nice job, smart girl. Tangent of theta. Kobe, what'd you get for tangent? 5 over 12. Nice job. Awesome. Totally right. Cosecant of theta. Who haven't I picked on yet? Daniel. Daniel's so talkative. Daniel, what do you think? Cosecant. 13 over?
5.
Perfect. Totally right. Secant. Who haven't I picked on in here yet this morning? Julia? Have I picked on Julia yet?
You have.
Okay. What do you think?
For which one?
You can do this one. Or Leah could do it. What do you think? Go ahead, do it, Julia.
13.
13 over?
12.
Yeah, how'd you get that so fast? You knew it was the opposite of that, didn't you? And Leah, what do you think about cotangent? How'd you get that so fast? See how fast you are. Okay, so if I look at example 3, it's identical. So we need a triangle, right? So before I do anything, let's draw a triangle, okay? I need a triangle. I really do. It's going to help me a whole bunch. So draw a triangle. Okay, if I'm going to get so I need a right triangle. Whenever I do right triangle trig, it's called right triangle trig. It's called right triangle trig. So we need a right triangle. So draw a right triangle. I'll put theta here, okay? And then let's see, cosecant. What is cosecant? Cosecant of theta. Let's see. If I look at my notes, cosecant of theta is the hypotenuse over the opposite, okay? So that means my 6 would be the hypotenuse, and my 5 would be the opposite. So let's see, this would have to be my opposite. This is my adjacent, and that's my hypotenuse, right? Hypotenuse is always along the side opposite the 90, okay? Opposite is always opposite. So I know that I'm going to put a 6 right here, and I'm going to put a 5 here. Okay, and I need to find the missing side. I need to find the adjacent side. How do I find the adjacent side? We just did it. How do I find the adjacent side? Yeah, Pythagoras theorem. So I'm going to go, okay, I'm going to go 5 squared plus b squared equals 6 squared, right? (25) plus b squared equals 36, right? Minus 25 minus 25. B squared is 11, right? Square root. B is, okay, it's the square root of 11. And let's leave it as the square root of 11. I mean, we could get a decimal and get some ugly decimal answer, but let's just leave it as square root of 11, okay? So I'll go back to my triangle and put in the square root of 11. All right, so let's see, what do we got to find?
Does it matter what side you choose, like what you choose of the two?
It won't matter at all. If you put theta here, really good question. Then the only difference is that the 5 would go here. But your answer is going to be the same. Whatever answers I have here are going to be the same answers if you put theta there because my numbers would switch around. Okay, really good question. Okay, do it. Sine. I want you to do this. Sine of theta. Tell me what the answer is. Cosine of theta. Tell me what the answer is. Tangent of theta. Tell me what the answer is. Okay. Cosecant of theta. I already know that one. I'll tell you what the answer is. 6 over 5. I know that one. Okay. Secant of theta. Tell me what the answer is. And cotangent of theta. Tell me what the answer is, okay? Well, I tell you, by the time we're done, everybody's going to be a right triangle trig expert. I sure hope so. Right, Julia? And if you get stuck, the ratios are up there, right on the board. Okay, give you a couple minutes to do this. And then I'll start picking on people. Who haven't I picked on yet? Have I picked on everybody yet? Have I picked on everybody? Trying to. Don't want to leave anybody out. Don't want to play favorites, you know. Okay, Seth, what'd you get for sine of theta? 5/6, yes. Everybody agree with that answer? 5, opposite of hypotenuse. There it is, boom. Okay, opposite of hypotenuse. Cosine, let's see, Alex, what'd you get for cosine?
Square root of 11 over 6.
All right, square root of 11 over 6. Yeah, that answer is okay, because the square root on the top is good, right?
Yeah.
Tangent. Vicky, what'd you get for tangent? Okay, it's going to be 5 over the square root of 11, but we can fix that. I like this answer better. 5 square root of 11 over 11. That's a better answer, right? Because I'm going to fix the problem. Secant. Autumn, what'd you get for secant?
Secant, isn't it 6 over square root of 11?
Yeah, yep. But let's fix that. How about 6 square roots of 11 over 11? That's a better answer. I like that answer better, okay? Yeah. And then finally, cotangent. Parker, what'd you get for cotangent? Square root of 11 over 5. Yeah, nice job. Okay, now, example 4, almost done. So, 90 minus theta. So let me go ahead and look back at this triangle, okay? Okay, let's look back at this triangle, okay? So if this is my angle, theta, right? Then 90 minus theta, I think theta is the other angle. Okay, if this is 30, that'd be the 60. If this is 20, that'd be the 80, right? So this 90 minus theta is the other angle. Okay, you going? Okay, did you get homework?
No.
Okay.
Here you go. Thanks.
So let's take a look. So let's redraw this triangle real quickly. And if this is theta, ooh, let's have a new symbol. How about this symbol? Beta. How about a new symbol? So this was the square root of 11. This was the 6, and this is the 5, right? So what I did is I took my triangle, and I just looked at the other angle. Because Autumn, you asked that, didn't you? So I just looked at the other angle, that's all. So if I do the same things, then all of a sudden, this side is the opposite. This side is the adjacent. And this side is still my hypotenuse, okay? So if I want my trig from this angle, if I want the sine of beta, the cosine of beta, and the tangent of beta, if I want the cosecant of beta, if I want the secant of beta, and if I want the cotangent of beta, I can do that. Can you guys, this last one, can you do it from this triangle? Okay, give it a try. I'll give you a couple of minutes, see if you can do it, okay? You're already done, aren't you? Easy. 2 thumbs up, huh? This is my opinion. Trigonometry sounds hard, but it's one of the easiest things we do. If you get today, if you do not get today, then you're in big trouble because it just goes from there, okay? You have to know what the opposite and adjacent and hypotenuse are in relationship to those. You have to. Okay, it's imperative. Okay, so sine of beta. Real quickly, let's pick on Celeste. What'd you get for sine of beta? Well, let's see. Opposite over hypotenuse. Square root of 11 over 6. Okay. Cosine of beta. Leah, what did you get for cosine?
5/6.
Awesome. 5 over 6. Tangent of beta. Ethan, what did you get for tangent of beta?
Square root of 11 over 5.
Yes, square root of 11 over 5. Opposite over adjacent. Perfect. Cosecant of beta. Lily, what'd you get?
6 square roots of 11 over 11.
Oh, you are so awesome. Yeah, how about, well, first, I like your answer better than mine. 6 over the square root of 11, which is kind of a bad answer. And then you said, no, it's 6 square roots of 11 over 11. You are awesome. That's exactly right because you fixed it, okay? Secant of beta. Zana, what'd you get for secant?
6 over 5.
How'd you get that so fast? It's the opposite of that one, isn't it? Right? It's the opposite of that one. Perfect. Cotangent of beta. Isaac, what'd you get for cotangent of beta?
5 to the square root of 11 over 5.
Right. Okay. I like your answer better than mine. I got 5 over the square root of 11 because it really is the opposite of this one, but I like Isaac's answers better. 5 square roots of 11 over 11. Awesome. Okay, that's all I have. What do you think? Can you do ratios, trig ratios?